What's up, guys? So today we're going to work on the two-sum problem from LeetCode. We're going to check out the brute force solution, which will run too slow, and then we'll look at an efficient solution to see how those two compare. So you can go ahead and go to play.kotlinlang.org to use this online environment. So we're going to make a main function, and we're gonna try and get just this initial example running. So we're gonna create a val called input. It's going to be an int array of, and we'll just grab these values, put those there. Okay, and we're going to create an brute force output. This is going to be brute force two-sum. We're going to call it with input and a target of 9. So the two-sum, this problem, it's asking you, so it'll give you a array called nums, and our goal is to find two values that sum to the target. So in this case, 2 and 7 sum to 9, so we want to return the indices of 2 and 7, which are 0 and 1. So this would be the output of this function, is the array 0, 1. So we wanna do that here. Let's see. So print line. We're gonna print brute force output, and content to string, which turns an array into a string representation. So we can take a look at it. And then later on, we're going to make a val efficient output. And this is going to be just our regular two-sum algorithm. It's going to take input and 9, and then we're going to go ahead and print that out. Print line efficient output content to string. So if we run this now, it's not going to work. We're going to get an error. Unresolved reference, brute force two-sum. That's because we haven't defined this function yet. So let's go ahead and define it. Brute force two-sum. And this is going to take as input nums, which will be an int array, target, which will be an int, and it's going to return an int array. Okay, so in order to check every single pair, so we'll use a for loop, two for loops, right? The first for loop will be our first element, and the second for loop will loop over the remaining elements. And so for each pair, we'll check, does this pair sum to the target? If it does, return the indices of that pair. So let's see how we do that. So the dot dot creates a range between 0 and nums.size minus 1, including this end number here. So nums.size, that returns the number of elements in nums. And we do minus 1 because indices are 0 based. So the indice of 2 is 0, and the indice of 15 is 4 minus 1, 3. Okay. So now we want to return if nums I plus nums j equals the target, we want to return an int array of I and j. And if we loop through all of these and we don't find a pair, then we just want to return an empty int array. And so let's go ahead and print this out and see what happens. Okay, so we've got our brute force solution working. But if you take a look at this and you think about runtime, this first loop is going to run n times, n nums.size times, and the second loop is going to run nums.size times. So this is going to run, this is having a worst case runtime of n squared. And so if we get a really big array, like this is going to take a long time. If we get a 1,000,000 row array, it will take on the order of 1,000,000 squared seconds to finish. So we can do better. We can use a hash map, and we can for each element, we can compare each element to the target. So we can say 2 target minus this 9 minus 2 is 7, and so we can store the number 7, and we can say if we come upon the number 7, look to this index to find its complement. And then we can go on to 7, and we can say if we find the number 9 minus 7, 2, look for index 1. 11, 9 minus 11, negative 2. If we find negative 2, look for index 0, 1, 2, and so on. So that's what we're going to do. We're going to compare each element to the target. We're going to store the complement and the location. So let's go ahead and get started here. Fun, we're going to call it toSum. And it's really similar, so we can just copy this. And delete this. Okay. Alright. So we're going to call this a memo, like for memoization. Memo is going to be a hash map. And we need to tell it what are the types for the keys and the values. It's going to be 2 ints. And we should leave a comment just to explain what we're doing here. So in our map, we're going to hold target minus nums I in the key, and for the value we're going to hold the index. So say we're going through here and we get to number 2. We're going to store 9 minus 2, 7 with the index 0. So we're going to store, ours is going to look like this. 7, 0. And then we're going to store, we're going to get to 7, and it's going to return because we found that number. But if we were adding this element to our memo, it would be 2, 1. And if we're getting to 11, it would be negative 2, 2. And if we're getting to 15, target minus 15 is negative 6, 3. So say this array had negative 6. Then we know that if we get to negative 6, we look inside of our memo, we see, oh, negative 6. Pair that with the third element, the element at index 3, which is 15. So if we look and then we add these two together, 15 plus negative 6, it's our target value of 9. So that's the way we're going to store these values. Okay. And so now we're going to loop through one time. And we're going to check if for each value we're going to check and see is that value in our memo. Does our memo contain key so if we're on 2, does our memo contain 2 and the index of 2's complement? So if we do find the complement in our memo, we're going to return an int array of memo.get nums I and I. So what this is going to return is, let's say we've gotten to we start with 2. Okay, is 2 in our memo? Is 2 in our memo? No. Okay, then we're going to put 9 minus 2. We're going to put 7 0 in our memo, and then we're going to go to 7, and we're going to check in our memo. We're going to see, is 7 in there? Yes, 7 is in there. So we're going to return, we're going to get 7, which will return 0, and we're going to return 1, which would be I in this case. Okay. If our memo is empty or it doesn't contain nums I, we're going to put nums I we're going to put it in the memo. We're going to put the complement. So target minus nums I. Okay. And let's see, what is this error? Something cool about Kotlin is it allows you to track nullability better. So memo.get may sometimes return null, and so that's why it's saying an int question mark means it's either going to be an int or null. Int without the question mark assumes that there's no null. So the way we can get around this is we can say we can guarantee that this value is not going to be null because we've already checked that the memo contains this value. So this should be a safe call. Okay. And now if we don't find anything, we just want to return an empty array. Okay. Alright, and now let's try our efficient output. Okay, so that's an efficient output. So let's look at the runtime for this algorithm. So it's only going to run through nums, each element of nums one time. So this is O of n. Whereas if you look at this brute force solution, it has 2 for loops. So it's going to run through all of the pairs in O of n squared, worst case time. And so that's why this is an improvement. So if we have a 1 million row array, this is going to take 1 million squared seconds or microseconds, but this is only going to take 1 million seconds. So it's a big improvement. Alright guys, that's how you do the two-sum algorithm in Kotlin. Thanks, and see you next time.